Okay, so we're going to look at another hypotheses testing example. And this one I thought I would go ahead and look at one of your homework examples. Also, I'm going to try a slightly different method of video. So I'm going to try to work the problem out with you and not have so much clicking, just to speed up the process a little bit. These problems are so long that I feel like a 30-minute video gets hard to follow. So let's see if we can't change this up a little bit. So this is like homework 9B number 1. It says test the claim that the mean GPA of night students is smaller than 2.8 at the 0.10 significance level. I would stay away from trying to answer this next part right away. I would wait until you have worked through the steps of the process as I've outlined in the PowerPoint example. Same thing down below here. We don't want to start answering about the test and the tail and all that until we've done some of the rest of the work in the problem. And then down here, it's giving us the sample data. Based on a sample of 75 people, sample mean GPA was 2.77 with a standard deviation of 0.05. It's asking us to find the test statistic, the p-value, and then determine whether or not we reject the null hypotheses or fail to reject the null hypotheses. So I copied that back over into notebook here. And I took out the relevant parts to test the claim that the mean GPA of night students is smaller than 2.8 at the 0.1 significance level. And based on a sample of 75 people, sample mean GPA was 2.77 with a standard deviation of 0.05. So we need to identify the hypotheses and the sample statistics. Sample statistics. Sorry, my pen's not working. Hang on 2 seconds. Okay, I think I have that figured out. So our sample statistics, let's see. Let's go with black. N is 75. And we have a sample mean GPA, X bar, of 2.77 with a standard deviation of 0.05. So we have to be careful here. Does it say population standard deviation? No, it does not. So that automatically tells us that it's the sample standard deviation. And it's 0.05. Then we need our significance level, alpha, and that's 0.10. Because we don't know the population standard deviation, sigma is unknown, we'll be using the t-scores. In other words, the student t-distribution as opposed to the standard normal distribution when we go to draw our picture and when we go to use our functions in Excel. So what are our hypotheses? Okay, so the claim is that the mean GPA of night students, that's our population mean mu, is smaller than 2.8. Mu is less than 2.8 is the claim. We want to know what is the opposite of that. The opposite of that claim would be that mu is greater than or equal to 2.8. One of these two is our null hypothesis, and the other is the alternate. The null hypothesis is the one with the equal sign. So that's the one downstairs here. The other is our alternate hypothesis. The alternate hypothesis will determine the picture. So it's a less than, I'll draw a normal curve, or it's not actually normal, it's the student t-distribution, but it looks like a normal curve. And it still has a mean of 0 in the middle. And we're looking at a less than for our alternate hypotheses. So that tells us it's a left tail. which is over there. And we only have one tail, and I'm looking for in the next step, my critical value T alpha, which is the boundary of that tail. And how am I going to find it? I'm going to know that over here, I've got how much area, whatever alpha is, 0.10. So we're going to scroll down, and we're going to find T alpha using Excel. T alpha is going to be given by T dot inverse, because we know the area to the left, and it's going to want to know a couple of things here. It's going to want to know the area to the left and the degrees of freedom. So degrees of freedom will always be, for this case, whatever the sample size is, -1. So our area to the left is 0.01. I'm sorry, 0.10. And our degrees of freedom, I gotta look up here, what n was 75, so we have 74 degrees of freedom. I have no idea what that is, so we're gonna jump over to Excel and maybe slide that up, equals T dot inverse. And again, it wants the probability to the left, so that's 0.10, because I'm dealing with a left tail, and the degrees of freedom is 74. That's -1.29. I already rounded it to 2 decimal places. You can see, oops, if it was more, it would be more, but I want to take it to 2. -1.29. So my critical value, T alpha, -1.29. And my picture, I'll just redraw it. That means that this boundary level here is -1.29. That kind of makes sense if 0 is in the middle. And that area still is the 10%. Okay, so now I want to calculate this test statistic. Again, I'm going to use Excel to do it, but let's figure out what these values are first. So the X bar comes from the sample statistics. Scroll back up. It's 2.77. We might wonder, where does the mean come from? The mean comes from the null hypotheses, where this equal sign is. So this equal sign here tells me that the mu equals 2.8. So this mu that we're talking about here is this 2.8. The sample standard deviation, I believe, was 0.05. Yep. So S is 0.05, and my N was 75. So divide that by the square root of 75 to get my sample, or excuse me, my test statistic. And we're getting this because we want to see whether or not it is in the tail. And when will it be in the tail? It'll be in that tail, in this case, if this number is less than -1.29. So anything else would not be in the tail. Let's jump over to Excel. How do I plug this into Excel? So as long as I put a parenthesis around the top, 2.77 minus 2.8, parenthesis, and then divided by, and a parenthesis around the bottom, 0.05 divided by SQ square root of 75. Tab out of there, it's -5.12 if you round it to 2 decimal places. We don't really, well, we do want to round it because we need to enter those into the homework. So it said to round it. Well, let's make sure. it wants the test statistic rounded to 2 decimal places. Excuse me. So negative 5.20. I want to go back to my worksheet here. Write that down. Test statistic is negative 5.20. That's my TX bar. And, you know, clearly in our picture, where is that? That's way over here. Really far over there. So this is in the tail, for sure. And what happens when it's in the tail? We want to go to our conclusion sheet, get a little cheating going on here. If the test statistic is in the tail, or the p-value is less than alpha, the evidence rejects the null hypotheses. I'm just going to copy that. Paste it in over here. Evidence rejects the null hypotheses. So I want to scroll back up and look at my original hypotheses and determine, you know, for the homework, it doesn't matter because it's only asking about the null hypotheses. But in general, we want to know about what's happening with our claim. So in this case, my claim is not the null hypotheses. So I would have to switch, and I would have to switch the word reject to the word support, and the word from the null hypotheses to the alternate hypotheses. And the reason I'm doing that is because this is my claim. And then we would say there is evidence to support, the claim. And, you know, we might reiterate what the claim is. The claim is that the mean GPA of night students is less than 2.8. And technically we would be done, except this problem in WAMAP is also asking for the p-value. So scrolling back up, the p-value is going to be the area that's more extreme than this test statistic. So negative 5.2 is my test statistic here. My p-value is everything to the left of that. I can tell by looking at this that that's going to round to 0 because 5 standard deviations away is pretty small. So, but let's go ahead and do the math. That's an area to the left already. So to find an area to the left, because I'm using a left tail there, area to the left. So you really need to evaluate the picture of the test statistic. This is not always the area to the left. It depends on what the picture looks like. It's the area more extreme than the test statistic. And so that's going to be found by taking t.distribution. And let me just jump over to Excel real quickly and see what are the parameters it wants for that. Equals t.distribution. It wants the value of x, so that is our, I'm going to switch to my pen again. It wants x, that's my test statistic. And then it's going to want my standard deviation, I think. My degrees of freedom and whether or not it's cumulative. Okay. Show you there what those are. Oops. It wants the test statistic for x, the degrees of freedom, and then whether or not it's cumulative. So our test statistic is negative 5.20. The degrees of freedom is n minus 1. So that's 74. And its cumulative value is true. I'm pretty sure this is going to be 0. Let's go back to Excel and plug it in. Negative 5.20, comma, 74, and true. Yeah, so to 4 decimal places, that's 0. Certainly to 2 decimal places, it's also 0. So my p-value is essentially 0. .00. So clearly the p-value is less than alpha. And again, that has the same conclusions as the test statistic being in the tail. The evidence rejects the null hypotheses. The evidence supports the alternate hypotheses, or there is evidence to support the claim that the mean GPA of my students is less than 2.8. I'm just going to jump back over to the homework site and enter these answers in and see if we got it right. So now, how would I take what I just did and answer these questions? So scroll up, look for our hypotheses again. Our null hypothesis is that mu is greater than or equal to 2.8. So we have to just look in here. We can ignore the ones with p's. Mu is greater than or equal to 2.8. That's the null. That's the one we want. So notice I can just base this answer pretty much exclusively on the null hypotheses. On the null hypotheses, yeah. Out of all these choices, this is the only one that has the correct null hypotheses. Make sure that's right. Mu is greater than or equal to 2.8. Yep. Switch back over. My test. The test is right-tailed, two-tailed, or left-tailed. This is a left-tailed test. Click on that. The test statistic is the negative 5.20. And the p-value is 0.00. Both those to 2 decimal places. I did that already. And our conclusion is that we reject the null hypotheses. Cross our fingers. Yay. Okay. So recapping this problem, I did want to plug those answers in because in case I had made a mistake or something, and then we can just catch it right away. Just recapping this process, listing out the hypotheses type and the sample statistics, stating the claim and its opposite. The one with the equal sign is the null hypotheses. The other is the alternate. The alternate determines the type of tails. So a less than in this case determined that it was left-tailed. A greater than would be right tail, and a not equal to would be two-tailed. Then we find our critical value using Excel because I do not know the population standard deviation. It tells me to use the t-scores or the t-distributions. So t dot inverse in this case, because I know the area to the left of this value, 0.1. And then degrees of freedom is n minus 1, 75 minus 174. I get my critical value. That's where the tail begins. I then can find my test statistic using the formula provided. Plug everything into Excel. We got a test statistic of negative 5.20. It's clearly in the tail. That gives us our conclusion. The evidence rejects the null hypotheses. The evidence supports the alternate hypotheses, which is our claim. That's why I switched, because my claim was not the null. If my claim had been the null hypotheses, then the evidence would reject the claim. And then we can write out that sentence about the evidence, whether it supports, rejects, fails to reject, or fails to support. Finally, the alternate method of finding the p-value. We're finding the area more extreme than this test statistic. So when I say more extreme, I mean in the tail, or if there's two tails, it would be the area on both sides more extreme than the test statistic. In this case, the area was essentially 0, and the conclusion is the same. So I think this went a little quicker. I'm hoping it did. It'll allow me to do, well, it'll allow you to watch more and for me to probably do a few more videos. And I think probably more examples is better than less. All right.